Tonight, I'll be discussing management information systems up to optimization analysis of Chapter 10. Management Information Systems, or MIS, produces information products that support many of the day-to-day decision-making needs of managers and business professionals. Personally, I believe MIS is computer science applied to business. Now, I'll be tackling about the four major reporting alternatives by MIS. First is the periodic scheduled report, which is a pre-specified format designed to provide managers with information on a regular basis. Examples of which are daily or weekly sales analysis and monthly financial statements. Exception report is kind of report produced when exceptional error occur. In other cases, exception reports are produced periodically but contain only about these exceptional conditions. It reduces information overload as this report only shows that details that really matter to the manager. Next are the demand reports and responses, which give immediate responses to the manager's immediate queries. Examples of these are web browsers, database management system, query languages, and report generators. And last is push reporting. In this kind of reporting, information is pushed to a manager's network station. Many companies utilize webcasting technology for this kind of reporting. Now we go to online analytical processing, or OLAP in short. OLAP enables managers and analysts to interactively examine and manipulate large amounts of detailed and consolidated data from many perspectives. It involves analyzing complex relationships among thousands or even millions of data items in data marts, data warehouses, and other multidimensional databases to discover patterns, trends, and exceptions. An OLAP session takes place online in real time, with rapid responses to a manager's or analyst's queries. OLAP consists of several basic analytical operations, but we'll only discuss three. First is consolidation, which involves the aggregation of data and involves simple roll-ups or complex groupings involving interrelated data. Data about sales offices can be rolled up to the district level, while district level data can be rolled up to regional level perspective. Next is drill down, which is the reverse of simple roll-ups. In drill down, detailed data that comprise consolidated data are displayed. Another OLAP basic operation is slicing and dicing of data, which refers to the ability to look at the database from different views. One slice might show sales of a product type, while another slice might show sales channel within each product type. Oftentimes, OLAP is performed along a time axis to analyze trends and find time-based patterns in the data. Here are some common business areas where OLAP is effectively used, which include marketing and sales analysis, clickstream data, database marketing, budgeting, financial reporting and consolidation, profitability analysis, and quality analysis. Now we move on to Geographic Information System, or GIS. GIS is a decision support system that uses geographic database. Many companies use GIS with Global Positioning System, or GPS, to help them choose new retail store locations, optimize distribution routes, or analyze demographics of their target audiences. Popular GIS softwares are MapInfo and Atlas GIS. Data Visualization System or DVS is a system that represents complex data using interactive 3D graphical forms such as charts, graphs, and maps. GIS and DVS concept is not a new concept. Back in September 1854, Dr. John Snow determined the source of cholera epidemic in London by marking the location of the home of each victim with a dot on the map. He also marked the locations of water pumps in the vicinity. Based on his study, it was found that the cholera victims all lived near and drank from Broad Street water pump. The handle of the pump was then removed, which ended the cholera epidemic. Decision Support System, or DSS, involves an interactive modeling process. Four basic types of analytical modeling activities are what-if analysis, sensitivity analysis, goal-seeking analysis, and optimization analysis. First, we tackle what-if analysis. Here, the user makes changes to variables or relationships among variables and observes the resulting changes in the values of other variables. As shown in the slide, we have two variables, which are interest rates and terms. Changing one or both of these variables would result to different amounts of payment. In sensitivity analysis, only one variable is changed repeatedly, and resulting changes on other variables are observed. You can watch a demo of sensitivity analysis after this video. For goal-seeking analysis, a target value or goal for a variable is set and other variables are repeatedly changed until the target value is attained. Again, we also have a demo of goal-seeking analysis after this video. For optimization analysis, I'd like to demonstrate it through screenshots via Excel. Here we can see products A, B, and C, and we also have variables for each product, which are the number of units, the sales price, the cost, profit margin, and total profit for each product. We also have the total row, which sums up the number of units sold and total amount of profit from sales of the three products. So in order to determine the maximum total profit that we could get from this data, just go to Data, then click Solver. Put the cell number of the total amount of total profit in set target cell. Then select Max to get the maximum amount of total profit. Put cell numbers B2 to B4 in the by changing cells space. Then we set constraints for cells B2, B3, and B4, all of which are set to be greater than or equal to 0 to return positive values. B5 is set to less than or equal to 300, assuming production of units won't exceed 300. Then click Solve. As a result, maximum profit that we can get is 5,400, where all 300 units sold were allocated for product B, which has the lowest cost and highest profit margin. This wraps up my demo for optimization analysis using Excel.